Howdy folks, my name is Arul Verma and today we're going to be going over the second part of our structs in CS128 honors. So the goal for today is to review some information about structs and look at some sample struct code. It's going to be a relatively short lecture, but feel free to ask us any follow-up questions in the Discord if you do have any. So we talked about this last week, but what is a struct? Well, a struct is a custom-made data type that holds multiple values of multiple types. You have to specify the type of the data that you're storing, but otherwise you can store as much data as you want to, unlike a tuple. And an object of a type struct is called an instance of that struct, much like an instance of a class. And structs are fundamentally very similar to classes as they are in other object-oriented programming languages, such as the fact that instances do not share variables and they do share global functions. And you can declare those functions using a trait or with a method, and you can declare other functions with the IMPL keyword, sorry, I should say. And much like other things in Rust, you can declare structs prior to the methods in which they are actually being used in. And we talked about this last week. This is some sample code we looked at to how to create a struct. Here we have a struct user with our data inside. We create a mutable instance of this user, and then we modify the email of this instance that we've created. So now let's go back to talking about struct methods. Remember that if we want to create a function for our struct, we use the keyword IMPL. In this case, we have our struct rectangle with a width and a height data, and we're implementing a function area for our struct. You can have multiple IMPL and multiple function within each IMPL, and each function accepts a borrowed instance to access the data of that instance and modify that data or do anything with that data. All methods in an IMPL require you to pass an %self, irrespective of the use of that function. The sole exception for this is a constructor or an associated function, which I'll go over in a second. And you can see here kind of how the syntactical layout of a function is. We use fn, you give it the name, you pass in a borrowed of an instance, and then you access the data of that instance. Now, this is a more fleshed out example of this. We can see here we have an IMPL rectangle with a function area, a function can hold, and then we create 3 rectangles, and we print out can rectangle 1 hold rectangle 2 and can rectangle 1 hold rectangle 3. And let's just go over a bit more of what we're doing with can hold. So the goal of the can hold function is to see if our rectangle can hold the second rectangle. In other words, is there some dimensional space in which that second rectangle can fit inside our first rectangle? The way we're checking that is checking to see if our width is greater than the second rectangle's width and our height is greater than the second rectangle's height. Notice how we're passing in the data to this function. We're passing in our instance, the first instance, as an %self, which makes sense. And the second rectangle is being passed in as an ampersand rectangle, as most data is referenced. This is a borrow, right? The ampersand represents a borrow, and rectangle being the type of data. And we don't use the keyword capital self here because capital self refers to the class as a whole. Instead, we use specifically rectangle to specify the data that we're passing in. So now let's go back to the self thing. Now that I've briefly brought it up, the capital self without an ampersand with capital S represents an alias for the entire struct rectangle rather than instance of a rectangle specifically. So in this case, this self referred to an instance like rect1, rect2, or rect3. Capital self refers to rectangles as a whole. These functions that don't take in an ampersand self, they aren't called functions. Instead, they're called associated functions. And you call them in the class by using the dot dot notation. We can see here we have rectangle dot dot square, and they're typically used for constructors like they're demonstrated below. So one question you may be asking is, here we have an ampersand rectangle. This represents a borrow, but what if we had a pointer to a rectangle instead of a instance of rectangle itself? That also kind of gets rid of the need of a borrow and it sets us up for success, right? So if we want to do a pointer of a rectangle and we want to call a function on it, would we have to use an arrow like we did in C++? And I'm sure you're all getting familiar with this in CS128 honors, how like pointers use the arrow to call a function, whereas instances, general instances, use a dot notation. Well, the answer is Rust has something really nifty called the automatic reference and dereference. And essentially all this does is Rust compiler looks at what you're passing into the function in the %self field, and it automatically references and dereferences until it has an instance. And it does the same for all other pieces of data. So the same applies to other, where it would automatically reference and dereference until other is the exact, as long as the same base data type is the same, so rectangle, and the object you're passing is an instance of rectangle, it'll automatically reference and dereference until both of them are a rectangle. So this really makes it convenient to make sure that you can just make your function definition to be ampersand self, ampersand rectangle, and then have everything that you pass in be automatically dereferenced, and it makes it very easy and readable for your code. Instead of having to go through like the process of putting in multiple arrows, putting in multiple references and dereferences until you have the correct data types, it's very low stress, and it makes pointers very easy to handle. So another question that could be brought up is, say we want to debug our code and we want to print a struct out. So we have a struct rectangle here with width U32 and height U32. And in our main, we're just creating a rectangle and we're printing it out. Well, the error we'd get is rectangle doesn't implement standard format display. Now, we could import format and then implement display, but that's kind of tedious and kind of annoying. And while this is entirely possible for debugging, there is a much easier way to go about it. Instead, we can use the colon and question mark for our format string instead of doing just the curly braces. And this is typically used in debugging. And the reason for this is because instead of doing the format display as it typically is in programming, or as it typically is in a format string, we instead tell the compiler that we don't want to be using format display, we want to be using debug. And the difference for this is that the compiler doesn't have to go through all these hoops and logic pieces and outside libraries to actually print it out. It just goes through the debug file. But we can see here that we still get an error. We get rectangle doesn't implement debug. So there's a really nifty piece of code that we've been using everywhere for debug, and I'm not sure if you guys remember it, but if you do, kudos. We just add the hashtag derive debug to the top of our code. It would go right here above the struct rectangle, and then we can print out our rectangle. And what it would print out would essentially be rectangle width U32, height U32. In this case, it would be width 30, height 50. And this would let us print out our rectangle and access that data and read kind of what the inner data of a rectangle is without having to actually print out in each function that we're working with a rectangle in or do different pieces of logic to actually work with a rectangle. We can just print it out with this single line, and it makes it very easy to access and kind of manipulate our rectangle and check to make sure that what's inside is what we think is actually inside. So the final thing I want to go over today is something called a tuple struct. So a tuple struct is a condensed format of a struct. It's not a tuple, it's not really a struct, it's kind of this a mix between the two. Basically, what you need to know is it is declared with the struct keyword, but it is functionally the same as a tuple and accesses data in the exact same way as a tuple, which is to say dot notation. They're mutable, and they allow you to distinguish tuples of interest from general tuples. So in this case, we can create a struct color with I32, 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 and we can say let black equals color 0, 0, 0. And this way we can specify the tuple of interest, in this case, any colors or any points, and we have let origin be 0.000. And to access anything here, it would just be black.0, black.1, black.2, origin.0, origin.1, origin.2. And that's how we can access individual pieces of data within our tuple structs. So that's all for this week. I know we went really fast, but everything here was just building off of last week, and there should be nothing here that is too difficult. If there is, feel free to reach out to us over Discord. Everything that we went over is also in Chapter 5 in the Rust docs, the textbook that we've been using for this course. So please make sure to read this entire chapter. It is very important and will be immediately relevant for MP2. Homework 7 has also been released, and make sure to review Lecture 8 for a much deeper dive into struct theory and how structs work. That is to say, last week's lecture. Thank you so much, and looking forward to see you guys next week.